Hi and welcome to DCO. In today's video you'll be seeing the full tutorial for this. I wanted to share with you from the beginning to the end all of the details that make up this building. We start with the initial details and expand from there. At the end you'll have a multi-floor building, and so this is perfect for those of you who are architects and designers who want to learn how parametric design works and how you can take your designs into this type of modeling. So thank you very much for being here. If you want to download this, you can go to my website and download it for free to see how it plugs in for a limited time. And there's also a bunch of other resources for those of you who are new. So thank you for being here. Hopefully you're excited, and let's jump right into it. All right, first thing we're going to do is bring in the component for line segment. This one's called SDL line segment, and it starts at a specific location. It has a specific direction and a length. So the start point is going to be using construct point. This gives us a parametric point that we can use to start. Then the direction is going to be unit X. Obviously you can change it to whatever direction you want to start in a different direction. And then the length is going to be the overall size for that line segment. So this way we technically could have done this within Rhino, created a line segment and brought it in, but this gives us a parametric line segment that we can extend. So now let's go here to 50. Now that we have this line segment, now we need to divide it because we need to be locating the doors and openings. So first things first is divide curve. Now I'll bring in that line segment and it will divide it, and by default it'll give us 10. So let's change that. We'll go to 5. And so now we have the ability to subdivide that line segment by however many subdivisions. So we'll make a max of 20 so you can see that we can change this. Here's the thing though. When you see this line segment, it is actually creating a point at the end here, and we don't need that because we don't need an arch opening at that location. So there are two ways of doing this. One, we could remove the start and end point here, or we can take this line segment, bring in a curve middle, so a midpoint, and then we can extend it or scale it down. So this is one way of doing it. Scale this line segment relative to the midpoint by, let's say, 0.8. So that makes it a smaller line segment, which we could use to divide that curve. So now you're seeing that we shrunk that line segment, and then here we have it subdivided. So now what we're going to do is, I'm going to show you actually a different way. This one is a little bit hard to be precise because you're doing 0.7 of the overall size of 1. So here's a different approach. Rather than using that, we'll go to extend, but instead of extending positive, we'll extend in a negative direction. And now we'll use, let's say, 5.5 to, instead of extending it, to shorten this line segment. As you can see here, this is the original and this is the new one. Now that's what we'll use to subdivide it. The reason why this is better is because it actually gives us a value, let's say 5 feet from the outside or 3 feet from the outside, and then we can now change the subdivisions here. All right. Next, we're going to be creating the wall segment. That's going to give us the base geometry that we can subtract the openings from. All right, so we got these points. We have this line segment, the original. Now, or let's see, yeah, the original here. Now we're going to take this line segment and we're going to move it in the Z direction by, we'll create a custom slider between 1 less than 15 less than 25. So that gives us a range from 1 to 25 and sets it at 15. Now we have the original line segment, the new moved line segment, and now we need to close it into a polyline. And one way I do that is endpoints, and endpoints for this one. So now that we have the endpoints and endpoints, we can create a line segment between the start points and the endpoints. And now join them. So join. And holding down Shift, I'm adding these two and the original curve that was moved up. So we got these two. Holding down Shift, add one more. And holding down Shift, I'll add this one. So when we look at the output here, we should have one closed polyline. We can also go here to flatten, and we make sure that this has one polyline that we could use. All right. So now that this, if you envision this being the wall segment, now those are going to be the locations for the doors. And this is going to be how it shrinks from the outside. Let's put it here. So now that we've set the stage, now we need to extract one of these points to create the form. It could be any form, but for this particular design, it's going to be an arched opening. All right, so let's do it. Let's take all of these points and let's just pick one of those. So to do that, we're going to go to list item. And the reason why we need that is because all of these points are contained within this component. And so if we bring this into the input, you'll notice that it only picks the first one. And that's because this lets you pick one of the items within this component. And the index of 0 is this first one. So now we can disable the preview on all of those and focus just on one, because if we do it to one, we could do it to all of them. So with this, we're going to move using the move component. We'll move the point in positive X and negative X. So I'll go here to unit X. I'll bring in a slider of 3.5. So now you'll see that it moves it 3.5 to the right, or in the positive X. And now we'll create a copy by sliding down, tapping Alt or copy paste. And now we need to give it a negative value, because if you think about it like this, it's going positive and then negative, and that's what creates the opening size. So 3.5 here and 3.5 here makes it an overall of twice as much. So now what we'll do is we'll divide by 2. So when you do a division by 2, it gives you an empty division component with A and then BS2 as we kind of plug that in. So what you can see here is that now this makes it the overall size of 5 or 2.5, 2.5, which makes it 5 here. Next, we need to bring these points up. So in the same way that we moved it in the X, this time we're going to move both of them in the Z direction. So we can bring this in, or the other way I like to do this is we're moving both of these again. So I'll slide it, tap Alt, and plug the geometry into the geometry and the Z into the motion. So I'll take this, tap Alt, create a copy here, and now we can use that slider to bring this up. So let's go here to 7. All right, so now that we've got the opening, now let's create the arc at the top. So there are different ways we can do this, but on this one, we're going to be arc seed, which means starting here, ending here, and direction is going to be up because it's going to be a full arc. So So now what we need to do is create the polyline that creates this whole form. So I'll bring in a polyline, which lets you plug in a bunch of vertices or points to create a line segment. So starting here, continuing down, holding down Shift, you'll see that it adds that line segment, then this one, and then this one. So now we can take these two and join them. And now it says one close planar curve. So now let's take what we have here, which is, let me show you. And you know, I'm just trying to keep this a little bit more organized so you guys can see how it all plugs in. But you can also download this from the website. So for now, let's change the opening size. And notice that however wide this gets, the arc actually increases in height. And that's to maintain this type of design. All right. So we've got this figured out. We've also got the height figured out and the vector for the arc. Okay. Next, like I said, we only picked one point, but what if we took all of them and grafted it? Notice that it creates it for all of them. Now the issue here is that maybe they're a little bit too wide. Maybe there's too many. And so the other thing is this, how far from the wall they are. And obviously, if you want to maintain, you know, this being the same as this number is where we can kind of shorten it. All right. So we've got this line segment, which is a close polyline, and all of these which are close polylines. So what we need to do is use a component called region difference. The reason why I like to use region difference is because you can get the same results that you can get with Boolean difference or Boolean intersection using region difference or region intersection, and it won't be as computationally intensive as it would be if you do a Boolean difference. So a lot of times you'll catch me using a region difference to subtract and then extrude. So using this curve as the curves A and this curves as curves B, now we can create a boundary surface to show you that here we're supposed to have the wall with the openings removed. But notice that there's this dashed line, which means that it's a grafted set, which means that it's going to be doing it to all of them separately. But when you flatten it, it does it to all of them at once. And that's technically what you want because check it out. Now we can move all of these and all of them will update now on a surface. All right, so now we got this, okay? Here's the interesting thing about this design. We're going to be creating a hallway or path here, and the arches that are in front are actually staggered. So for the next few steps, we're going to be recreating this wall offset here, but we're also going to be shifting the doors. So with that, let's go back because we have all of the work that we've done here. Now we can take this line segment and offset it. To the outside, so we'll go 6. We'll just do 10 here. Here's what happens. When you extend this out here by 10, you also have to extend the outside by 10 for this to maintain a square footprint. So that's what we'll do. We'll bring in an extend curve. So I'll just copy this over, use this as the input. And what number am I going to use? The same as the offset. So the smaller the offset, less that it offsets, of course. So now that we have this out here, we're going to be creating or recreating the wall the same way that we have it here. So how do we do that? Well, taking this, not this one, the extended line segment, and we're going to be moving it up like this one was. So now we'll bring in a move component. We'll use this as the input and then use that same extrusion for it to be the same height. I'll be using the same steps, right? Endpoints and connecting it into a polyline. So this one, and then this one. And then we'll redo this because we need to plug in the new ones. So it's going to be this one and the top one. So holding down Shift, I'm adding all of the inputs to create this closed polyline. Now we could have done this again by ourselves, just moved it up, create the endpoints, and close it into a closed polyline. So here we go. All right. So now what we need to do is take these and move them 10 feet or whatever distance this was to that same location. So we know it's Y in the negative direction. So move unit Y. These. Well, it's going to be negative. We know that because it's the other way. And then use this number because that's how much we offset it by, which means that that's how much we need to move them by. See if it clicks in. So technically, if our design was to have them lined up, this would work. We went to region difference, use the wall as A because that's what we want to keep, and we want to subtract B, which are these. Obviously, like on this one, we'll flatten the input, and you'll also see that here, that this is removed. Well, technically, this is how you would do it if you did not want them staggered, right? Lined up. But if you do want them to be staggered, there's a few other steps that we need to do here. And let me show you that. Before we do region difference, okay, now what we need to do is shift this by half of the distance between these 2 points. Because if this point and this point, if we shift this point to this point, it's lining up. But if we move it halfway, well, the door will be staggered. So how do we do this? Well, there are different ways we can do this, different ways to approach things. But the way that I like to do it is, let's figure out what that distance is. So we need to go back here and figure out where we subdivided the points. Then we need to pick this first point and second point. So list item, we'll plug this in. Notice that it picks all of them at once. That's because it's grafted, so we need to flatten it. And notice we have the first one, and if I go down here, we can add the second point. So if we create a line segment between the start point and this end point, well, this length is the length between doors, and therefore we can take this length and divide it by 2. So if you take a length and divide it by 2, now we'll be staggering this set. So now that we have this moved forward, we need to move it again, but in the X direction. So I'll copy this, tap Alt, plug this in, and now we're going to be using this number. That is that line segment divided by 2, but now we're going to be moving that in the X direction. And now we can shift those by half and disable the preview before. So if we look in elevation view, this is what's happening. We basically have moved the openings to the other side and shifted them halfway so they stagger. But do you notice what happens? We have removed this first one, this one. So we're missing one because if we shift it over, then we're missing the first one. If we shift it to the left, then we're missing the one on the right. To fix this, we're going to now go back to these. Now what I need to do is select the first one and move it over by the same amount as this line segment. So it's staggered, but in the same, using the same distance as this one is. Hopefully you're following along with that one because it's a bit tricky. So let's go here to list item. We'll pick the first one. Now notice that you can't pick the first one if it's a grafted set because it's doing it to all of them at once. So if we flatten the input on this one and we move this by this length in the negative X direction, so negative X direction, but I can't use the half because half is to stagger it. So I actually have to use the full length for that. It's going to be negative because it's going in the negative X direction. And now this completes the pattern. So no matter how many you add, you're always going to have one added at the end because it's shifted and then one added at the beginning. And then the length, you know, all right. If it's 100, do you see that? Okay, now we can do the region difference. So we have this set, this whole set here. So now we got to put them together. Merge this and this. And now we'll take this, which is the polyline, plug that into A because that's what we want to keep. And then we're going to plug in B, which is the results of all of that, into B. All right, that looks good. All right, so notice that we've got everything, but the most important parts are going to be the inside portion and the outside portion. So now I'll take all of this and disable preview. We can always bring back any information we want and we can reuse it and use it as a reference for other things. For now, with this, we're going to be creating the wall as a solid. So let's take this and we're going to extrude them in the positive Y. So extrude Y and then 1.50. And the same thing to the inside. Now we've got this line segment. We also have, let's see, the endpoints. No, midpoint. Let me show you why. Once we have the midpoint, and this can go anywhere, I'll bring it down here. I'll be rotating, or no, this point needs to be moved in the Y direction, or this way, by half of the overall length. So move this midpoint, like I said, in the Y unit. And if I use the same length as this, you'll see that it brings it all the way out there. We don't want that. We need length divided by 2. And I do like to hide the wire just so, you know, it doesn't overlap with everything here. So once it's moved halfway here, now we can use this as a reference point to rotate these surfaces around. Using rotate, we can also use polar array, but I like to use rotate, and this is how I like to use it. If I'm rotating something symmetrically, it's usually using 360 degrees. And so we do 360 divided by 4 because we're rotating it 4 times. So 360, you can just do division. And then here I'll show you, I'll use quotation marks 4 to create a panel that has that number. And so 360 divided by 4 equals 90. And now we're going to be creating a series of rotations using the step number of 90, the count of 4, and now we do need to change this angle to be degrees. Now that we have that, we can use this as the plane input, right? This point, and it's going to rotate these 4 times relative to that point. So 4 of the rotations. Oops, wrong one. So this is the plane. Now, okay, that was actually correct. That's a reference point. This is what we're using to rotate, and this is the geometry. So what we did with this is rotate it by 90 degrees 4 times, and therefore it rotates it 0, 90, 180, and 270, which we do for the outside and the inside. So now every side is symmetrical because we're using one side that is rotated all the way around. And so with this, we can go to union or solid union. And merge all coplanar faces, which removes this crease that you see here. So now I'd like to disable the preview on all of this and then just copy this down and do it again to the new one. So now let's take a look. Let's see what some of these things do. This one, there's a point in which the arches in the inside go too far. Let's see. All right, let's disable the preview on these. So let's try to make it a little bit smaller. We don't want it to get too crazy here. All right, so that's a little bit more manageable here. For this next part, we're going to be creating the floor above, right? And that's going to give us the module so we can array this also vertically. So there are different ways we can attack this. We could take this, create a box around it, pick the top surface and extrude it up. The other way is this rotates a segment out here around by 4. So if it brought this back, and instead of rotating, the wall, why couldn't we rotate the offset curve that has been extended? So this one. So notice that we've technically just rotated that line segment all the way around, and that actually creates the perimeter. So if I take that and I join it, and I flatten the input, we'll have a polyline that we can move up. So let's move this using the wall height. So this number, 16, in the z direction, that's going to be the vector. So we can bring this output all the way out there, or sometimes we can bring in an empty vector component, move this all the way out here, and use this vector with a hidden input. Now we can move this up. So let's create a boundary surface. And technically we can use this to offset, but I don't think we'll need to. But we'll still leave this here, just in case. It actually gives us a nice look. So if we offset to the outside, we can also offset by 0. So what this does is gives us the ability to have a bit of an overhang if we wanted to do that. So with that, let's take this and extrude it in the z direction. So up by 2. We'll go 2.000. So what did we do? We took the outside line segment, rotated it, joined it, moved it up, turned it into a surface, and extruded it up. So with this and this, now we can move and create a multi-floor building, but we need to keep in mind a few things. The vector that we use to move this up is this one, and this is the other vector that moves this up by 2. So we technically, to create the spacing, we need to add both A and B vectors, which is the wall height plus the floor or ceiling height. So that's what we have here, the result. Now I will hide the input. And now we can move this up by this, and also do it to the inside wall, the outside wall I mean, and also do that to the floor. Now this is not scalable in the sense that we've only created one vertical array. Why not use this number as a series so we can create multiple floors? So this is a step. The count will just say 5, which means 5 copies. and then zeros in the Z direction. So I'll double click here, override the step here, because now this number is going to be this one. Okay. So this creates a step of a consistent number, which is this height. Now let's give this a custom preview. So we'll go to custom preview so we can see it. We're not just seeing through everything. Now let's go here to color picker. And lastly, we need the floor. And you'll see here, let's see what it looks like when you have an overhang. It's not too bad. Yeah. The floor, well, we rotated this around, but this was the original. Hold on. This comes from and this gets joined. Then this also gets rotated and joined here. Okay. Boundary surface is here, and then extrude by -Z. So extrude. Since we have this number of 2, and that's the same as what we're going to be using down here, we can use this as a negative vector because we need to extrude it down, and then we can extrude that surface down like this. And yeah, let's expand this. Let's see what that looks like. And then see how many of these we can fit comfortably. All right, so this concludes the tutorial. I wanted to show this exercise where we create a multi-floor building. We start with the inside portion. We make sure that we add all of the details. And at the end, we have this building. So hopefully you found that useful. This is a full tutorial. Hopefully you learn more tips and tricks that can help you take your designs from just Rhino into the parametric world. So thank you very much for being here. Check this one out on the website. I also updated the website, so it should look a little bit different. And yeah, let me know if you have any questions. Look forward to seeing you on the next one. And thank you for being here. All right, so here at the end, now that we've completed the whole script, I'm going to take the time and clean it up. What that means is I'm going to relabel all of the components. I'm going to make sure that it's clean for those of you who want to download it and see what it looks like when it's completely organized. And then I'm going to take an additional step and actually turn this into a cluster. So you'll see 2 things here at the end that will be useful, and you'll also see when you download the file on the website.